Hong Kong has taller towers, newer towers, and towers that now dominate the skyline far more than the Bank of China Tower. But when this building opened in 1990, it changed what Hong Kong thought a skyscraper could look like. At 315 meters to the roof and about 367 meters to its mast tops, it wasn't simply tall. It was structurally unconventional. Engineers had to make an asymmetrical tower work in one of the world's major typhoon zones, while architect I.M. Pei wanted the structure itself to become the architecture. Some of the engineering logic is still remarkably effective. Some questions are simply questions of age, maintenance, and information. This is the Bank of China Tower. And the problem isn't fixed. The tower was commissioned by Bank of China as its Hong Kong headquarters, at a moment when the city was approaching one of the most politically significant dates in its modern history, the 1997 handover of Hong Kong from British rule to China. The architect was I.M. Pei, working through I.M. Pei and Partners, and the brief was unusually demanding. Create a distinctive headquarters on a constrained central site, make it unmistakably modern, and build it tall enough to become a symbol. Pei didn't hide the structure. He made it the building's identity. The inspiration was bamboo, specifically the way a bamboo stalk appears to rise in sections, becoming narrower as it grows. The tower begins as a large square form and progressively reduces until the upper structure becomes a triangular prism. It was an architectural idea, but it was also a structural strategy. And that matters. At completion, the tower was 315 meters high to the roof, with 2 masts extending the overall height to roughly 367 meters. It contained 70 main floors above the ground level, plus 4 basement levels, according to Bank of China Hong Kong. The Skyscraper Center counts 72 above ground levels, because Hong Kong's floor numbering conventions can exclude certain levels. In 1990, it was the tallest building in Hong Kong and Asia, and the first building outside the United States to exceed 305 meters. For a bank headquarters, that was quite a statement. And then the engineers started doing the math. In a normal tall building, loads are distributed through a more conventional frame of columns, beams, and core walls. The Bank of China Tower instead uses an external diagonal space frame system, with triangular frameworks transferring gravity and wind forces toward the major corner columns. The structural engineer was Leslie E. Robertson, and his firm, Robertson, Fowler and Associates. Here's the thing about the Bank of China Tower that every skyscraper engineer knows. Height isn't the only problem. Wind is. Hong Kong sits in a typhoon-prone region, so the tower had to resist forces pushing sideways, as well as gravity pulling downward. The diagonal system turns the exterior into a giant structural network, allowing the tower to carry lateral loads without filling the office floors with conventional columns. Think about what that means for a moment. The unusual shape isn't simply decoration. The diagonals are doing real work. When wind pushes the tower, the forces travel through the structural frame and down toward the foundations. The building moves because tall buildings move. That isn't automatically a defect. Controlled movement is part of high-rise engineering. But here's something about this building that nobody ever explains. The structure also created an unusually expressive interior and exterior. The glass curtain wall follows the changing geometry, while the triangular forms become smaller as the tower rises. The result is one of those buildings where the engineering can be read from the street, not slightly, not as a design flourish. The structure is the design. The difficult part was making all of this work economically and practically. The project used a composite structural system of steel and concrete, and the triangular framing reduced the need for a conventional dense grid of columns. That created more usable office space while also addressing the wind problem. But here's the detail nobody surfaces. The tower's technical achievement was accompanied by controversy that had little to do with structural engineering. Its sharp triangular forms became associated with bad luck by some feng shui practitioners and residents. Contemporary reporting described nearby residents placing mirrors outside windows in an attempt to reflect what they considered harmful energy. The building itself, meanwhile, kept doing something much less dramatic. It operated bank employees worked inside it. Elevators carried people upward. Air conditioning systems kept offices usable. Glass reflected the changing Hong Kong sky. And underneath everything, the structural system quietly carried the loads it had been designed to carry. That part doesn't make it into the architecture magazines. When the tower opened in May 1990, it immediately became a landmark. But the strongest evidence of its engineering isn't the height record anymore. It's the fact that the building has continued functioning for decades in the environment it was designed for. Compare it with other famous towers from the same era. Taipei 101 later used a massive tune mast damper to control wind-induced motion. The Shanghai Tower uses a completely different aerodynamic form and structural system. The Petronas Towers use reinforced concrete cores and sophisticated perimeter systems. The Bank of China Tower chose something much more exposed. Here is the fundamental difference between the Bank of China Tower and every other skyscraper we've covered. Its structural expression is unusually inseparable from its visual identity. And that creates the question that sits beneath all of this. What happens when an experimental-looking structure simply gets old? The tower opened in 1990. That means the building is now more than 3.5 decades into its life. Materials age, sealants age, mechanical equipment ages, glass systems require maintenance. Steel connections and concrete interfaces remain subject to inspection and upkeep, but there is no evidence that the tower is approaching collapse, and there is no verified public record showing that its fundamental structural concept has failed. That distinction matters. The real uncertainty isn't whether engineers know how buildings age. They do. The uncertainty is how every individual component performs over a particular building's full service life, under its actual environment and maintenance history. There is no historical data for what a Bank of China Tower looks like at 50 years, because no Bank of China Tower is 50 years old. It is the first. It is the only one. By 2040, engineers inspecting the building will have another decade of real-world history to study. They'll know more about the long-term performance of its materials, facade systems, mechanical equipment, and structural details than anyone could have known in 1990. And that is genuinely interesting, because today, someone can enter the tower, step into an elevator, hear the doors close, feel the floor begin to move upward, and look through the glass at Central spreading beneath them. They aren't thinking about load paths. They're thinking about work, money, meetings, traffic, lunch. None of them are thinking about how unusual the building actually is. And right now, the Bank of China Tower is still doing what it was built to do, standing, working, and carrying people through one of the world's most crowded financial districts. The unanswered question isn't whether it can stand today. It's how intelligently we can understand its next 50 years. Drop it below. Would you work inside the Bank of China Tower for the next 20 years? See you in the next one. Verify Bank of China Tower located at One Garden Road, Central, Hong Kong. Bank of China Hong Kong owner-operator associated with the tower. Bank of China developer/client. IMPay/IMPay and Partners Architect. Robertson. Fowler & Associates structural engineer listed by the Skyscraper Center. Construction began in 1985. Official opening May 1990. Roof structural height 315 meters. Height including masts approximately 367.4 meters. Main floors 70 according to Bank of China Hong Kong. The Skyscraper Center lists 72 above ground levels because floor counting conventions differ. Basements 4 levels. At completion, the tower was the tallest in Hong Kong and Asia. It was the first building outside the United States to exceed 305 meters. Structural concept external triangular diagonal space frame system transferring loads toward major corner columns. Design inspiration bamboo and its segmented growth form. Hong Kong is a typhoon-prone environment, requiring substantial wind resistance considerations in the tower's design. Contemporary reports documented feng shui criticism and residents using mirrors in response to the tower's sharp geometry. No claim is made here that the Bank of China Tower is failing or at risk of collapse. Available sources identify it as completed and functioning. Thanks for watching. Please subscribe to my channel.